What's up everyone, welcome back. Patrick here, and in this video we're going to do these two trig limits here. And notice that they are very similar. So in this first one we got the limit as x approaches 0 of sine x over 6x squared minus 5x. And then the second one is pretty much the same as this one, except there's a 4x here instead of just an x. So initially I just had this one, but thought I would add this one as well just to show you how that single small difference can make a difference in how we're going to solve these limits. And as I did in the previous videos, going to be using these results here to help me out in the process. So starting with number one, we've got the limit as x approaches 0 sine x over 6x squared minus 5x. And what we can do here is we can actually factor out an x in the denominator. So if we factor out an x, we'd be left with 6x minus 5 in brackets like that. And now what we can do is we can actually create two expressions here. So we'll have the limit as x approaches 0 of sine x over x. I'm going to put this over that. And then this I'm going to create as its own separate expression. Now since it's in a denominator, there's going to be a 1 in the numerator. And I'm going to put 6x minus 5 like that. And then what I could do, notice how we're taking the limit of two functions that are multiplying by each other. So using limit laws, we can say the limit as x approaches 0 of sine x over x times the limit as x approaches 0 of 1 over 6x minus 5. Now notice that this is the exact same as this. So we know that this limit here is equal to 1. And then notice for this, we can just do a direct substitution because the denominator won't be 0. So if we sub in 0 for x here, we'll have 1 over 0 minus 5, which would just be 1 over negative 5, which is just negative 1 over 5. And then 1 times negative 1 over 5, final answer ends up being negative 1 over 5 for this limit over here. So the reason why we factored out that x here is so we can get this expression, because we know that the limit of that expression as that theta approaches 0 is equal to 1, which we're able to use over here. Now what about number 2? What if that expression in the numerator is sine 4x instead of just sine x? How's it going to be different? Well, I'm actually going to start off the first initial steps as I did in the previous example. So I'm going to factor out an x at the bottom. So we'll be left with 6x minus 5. And then I'm going to create two expressions. So we'll have sine 4x over x times 1 over 6x minus 5. And then using limit laws, we can quote-unquote distribute that limit to both expressions. So we'll have that times the limit as x approaches 0 of this over here. So this, we know, we can do a direct substitution. It's just negative 1 over 5. Like we had in the previous example. But notice this bracket is different. Instead of sine x over x, it's sine 4x over x. But notice that it's actually in this format here, where we have sine mx over nx, where the m in this case is 4, and the n is 1. So we know the answer is going to be m over n, so we know this is going to end up just equaling 4, like that. But if you want to show the work here, so I did a video where I showed the work for getting this result here, but if you want to show it quickly here, what we can do is notice if you want to use this property here, this and this have to be the same. They have to be the same expression. So what we need here is a 4 in the bottom. So what we can do is we can multiply the top by 4, multiply the bottom by 4. So it's like we're multiplying this whole expression by 1. And now what we can do, I'm going to take this 4, put in front of this x, and then this 4 I'm actually going to take outside of the limit because it's just a constant. So this would end up being 4, the limit as x approaches 0 of sine 4x over 4x. Now we can do a change of variable. We could let theta equal 4x, and then as x approaches 0, here it means theta is approaching 0 as well. So with that change of variable, we would end up with limit as theta approaches 0 of sine theta over theta. And with this, we know is equal to 1. So you'd end up with 4 times 1, which is equal to 4, which is what we got here. So to go from here to here, this is how you show the work. And now going back to our main work, 4 times negative 1 over 5 is just negative 4 over 5. So that ends up being the answer, the limit to the second part of this example.